So let's solve a few problems on the concept we learned about magnetic field at the center of a ring. So let's solve this question. We have to find magnetic field at point P, okay, at the center of these two concentric semicircles. So magnetic field would be mu naught. We know that magnetic field by any arc of angle theta is mu naught I upon 4 pi r into theta. So we will use the same formula. So for this semicircle, it would be mu naught I upon 4 pi, and radius is r, and theta would be pi, and this magnetic field will be inside. Okay. So this magnetic field will be inside, plus magnetic field will be by this circle, this semicircle would be mu naught I upon 4 pi, and radius is 2r, okay, and the angle is pi, okay, and this magnetic field will be outside the plane, okay, and magnetic field because of these two lines will be 0, these two segments will be 0, okay. Why is it 0? Because the sign will be 0, sign 0 will be 0, so of course, so we can take out everything common, that is mu naught I upon 4 pi r, and this pi cancel, so we don't need to write pi at all. This is mu naught I upon 4r, and we can find here 1 minus 1 by 2, so this will be half, so this will be mu naught I upon 8r, and because this quantity is greater, so because we subtracted from this to this, so this will be outside the plane. So that's the solution of this problem. Let's solve a few more problems. So let's solve this another question, and this is a very easy question, but I don't know why it has appeared in J advanced. This has been asked in J advanced, so let's solve it. Now, to solve this problem, we have to find magnetic field at this center. We can use the idea of symmetry, and the idea of symmetry says that there are 4 arcs here and 4 arcs here, okay, and these 8 arcs construct 360 degrees at center. So therefore, by using symmetry, we can say that one arc construct 360 by 8, that is 4, and that is 45 degrees, okay. So this one arc construct a 45 degree angle at the center. Similarly, this arc construct 45 degrees at center. So, and we can see the direction because of all these arcs direction because of all this current carrying arc is same, that is out of the plane, okay. So let's solve it. So magnetic field would be, we will find first magnetic field because of this one small arc, and we'll multiply it by 4 because the direction is same and magnitude is also same. Then we will find magnetic field because of this arc, and we'll multiply it by 4 simply because the direction and magnitude is same. So because of this small arc, I am finding this is smaller arc, it would be mu naught I upon 4 pi, and radius is r, and angle is pi by 4, okay. And I because this is a one arc and there are 4 as such, so we will multiply it by 4, and we will find magnetic field because of this one larger arc, and we will multiply it by 4 again. So because of that larger arc, it would be mu naught I upon 4, let me write it more clear, mu naught I upon 4 pi, and radius is 2r, and angle is again pi by 4, and there are 4 such arcs, so we will multiply it by 4, okay. So this 4 cancels here, this 4 cancels here, and we can take, and this pi cancels, this pi cancels, and we can take this mu naught I upon 4r out. This is 1, and this is 1 upon 1 by 2, so this is 3 mu naught I upon 8r. And this is outside the plane, okay. So that's the answer. This has appeared in J advanced. This is an easy problem, so there is nothing to worry, and let's solve another problem. So let's solve this another question. This is even more simpler question, so let's solve it. So here we can see that there are three segments. So the one segment is this semi-infinite wire, the second segment is this semicircular arc, and this third segment is again this semi-infinite wire. So, and we can see that direction because of all three direction due to all three segments is inwards the plane, okay, is inside the plane. So, and this is, so let's find magnetic field. Magnetic field is, first we have to find this magnetic field because of these two segments, so we can find actually magnetic field because of one, and we'll multiply it by 2. So let's solve this another question. This is a more easy problem. First we can find it, that first we can analyze this question by that there are three segments. First segment is this semi-infinite wire, the second segment is this semicircular arc, and this third segment is again this semi-infinite wire. The direction of magnetic field because of all three segments is inwards the plane. We can see that it is inwards the plane, okay. And so we have to find the magnetic field. So first we will find magnetic field because of this, then this, and this. Interestingly, magnetic field because of this segment and this segment will be same, and because they are semi-infinite wire, so the magnetic field of semi-infinite wire will be half the magnetic field of infinite wire, and magnetic field of infinite wire is mu naught I upon 4 pi r, okay. So magnetic field of these two, of this segment is 1 by 2 of this, and because there are two such segments, so we will multiply it by 2, plus we have to find magnetic field because of this semicircular arc, that is mu naught I upon, that is mu naught I upon 4 pi r, and the angle is pi, so we can cancel this pi, and we can cancel this 2, and we can take this mu naught I upon 4 pi r plus of mu naught I upon 4r. That's inside the plane, so that's very easy problem. We'll solve one question from Herodov, and then we will wrap up. So the question is that there is a wire in this z-axis all the way from infinity, and this comes here, bends in xy plane, and again goes back in the xz plane. So again this goes back to this up to infinity, and it carries a current in this direction. It carries a current in this direction, and this is of radius r. So we have to find magnetic field at the center, okay. Again, this is a very easy problem. We can do this. So first we have to analyze that there are three segments. First segment is this semi-infinite wire, second segment is this semicircular arc, and this third segment is again this semi-infinite wire. But here the direction will be a little bit problematic. So first we have to talk about direction. Direction because of this will be inside the plane, okay, and direction because of these two will be in the same direction, and that will be in j cap, okay. If you, yes, that will be in j cap. So that will be in j cap, and the direction because of this semicircular arc would be in k cap, actually in, yes. So let's find it, let's solve it actually. So magnetic field is, and we can multiply the magnetic field by 2, just हम इसका निकालेंगे, और बिकॉज इन दोनों की magnetic field सेम है, so हम 2 से मल्टीप्लाई कर देंगे. So magnetic, and this is semi infinite wire, so magnetic field due to semi infinite wire will be half of infinite wire, that is mu naught I upon 4 pi r, okay. And there are two such wires, so we can multiply it by 2, and the direction is in let me just think about direction again. So direction would be in j cap, okay, and that will be in minus j cap, because angle, yes, that will be in minus j cap, and magnetic field because of this semicircular arc would be mu naught I upon 4 pi r, and angle is pi, and direction is minus k cap. Direction is this is minus j. Direction is k cap because direction of k is not defined. This can be positive minus z or plus z, that does not matter. So we can find this simply. So these two cancels, and the answer is mu naught I upon 4 pi r minus j cap plus mu naught I by 4 pi r. Sorry, this pi cancels, so there is no pi. This mu naught I upon 4r, and this is k cap. So that's the solution to this easy problem. We'll solve a few more problems, and then we'll wrap up.